So this is the last two questions from AQA 2019 November higher paper, and we are looking at, let's find out. So question number 27, a curve has the equation x squared minus 6x plus 17, and the turning point of the curve is at a, 8. By completing the square or otherwise work out the value of a. So we know that in order to find that, we go x squared minus 6x plus 17, and then we halve the coefficient to complete the square, halve the coefficient of x, square it, and that would give us x squared minus 6x, but it also gives us plus 9, so we're going to have to take 9 away, add 17. And so that should give us x minus 3 squared, and that is plus 8. So that is indeed, it's going to give us 3, 8. So the answer is x equals 3, or the x-coordinate for the turning point equals 3. Now, the turning point of the curve x squared plus 4x plus b also has a y-coordinate 8. Work out the value of b. So we know that in this case it's something, well actually we're going to know it's minus 2 and then 8. But we won't worry about that for a minute. So we'll actually start off by doing x squared plus 4x plus b, and then we'll make it x plus 2 squared, and then we're going to have to go minus 4 plus b, and that means that we know that minus 4 plus b equals 8. So in order to find out what b is, we add 4 to both sides, and we find out that b equals 12. So that is the value of b. And now we're going to go on to the next little thing, and we're going to do 28, which is, again, 100 to the minus a half. I do like indices laws. Now, what half means when it's in an indices is it means that it's the equivalent of doing that. So it's the equivalent of writing the square root. So I would break this into 2. So 100 to the power half, and then to the minus 1. So what we're essentially asking is, what is the value of the square root of 100? And the square root of 100 is 10. And now to the minus 1, that means flip it, make it the reciprocal. So it's 1 over 10, and that's our answer. Minus 1s are always worth bearing in mind that they are the reciprocal, and if you have something which has a minus in, always put it into 2 bits. Oh good lord, so this is going to be an integer, but so I've now got to remember what these things are, and I genuinely can't. So we're going to start off by drawing 30 times 8 tan 30 is an integer. So in order to do this, we will need an equilateral triangle where all of the angles are 60. Then what we do is we slice that in half, and we get a 30, and we get a 90, and we have, this is 1, this is a half, and so if that's 1 1/2, that means that 1 squared minus a half squared equals this, or adjacent, which would be squared, which would be 3 over 4, and it's the square root of 4, it's the square root of 3, so that's root 3 over 2. Now, using SOHCAHTOA, we know that sine of 30 would equal, let's use another colour, so sine of 30 equals opposite over hypotenuse. So sine 30 equals a half over 1, which is a half. And cos of 30 equals adjacent over 1, which equals root 3 over 2. And tan of 30, well, that's a little bit more tricky, because that equals half opposite divided by root 3 over 2, which equals half times, with a keep slip change, 2 over root 3, which equals 1 over root 3, but you can't leave a root 3 on the bottom, so we'll times out by root 3 over root 3, and we will get root 3 over 3. So finally, tan of 30 equals root 3 over 3. Now, 5 times sine, 5 times a half, times root 3 over 2 times 8 over root 3 over 3. So I'm going to do, that's 5 over 2 times root 3 over 2, which equals 5 root 3 over 4, times 8 root 3 over 3, which is 40 times 3 over 12, which is 120 over 12, which equals 10. There's a lot of different ways to do that, but you do have to try and make sure that you either know sine 30, cos 30 and tan 30, or you use your equilateral triangle in order to find them.